Hey guys, Mr. Rysz. We're going to start activity 114. We're going to do the first day's activities, and just like in 113, the first days, we have like our notes or our walkthrough, and then a submittable for part one, and the same thing for part two. We'll go through our walkthrough and do the submittable. It's just how it has to be organized here with all these different embedded things. I didn't want anybody to get confused. All right, so let's start with part one. Activity 114. So spinning with spiral graphs, part one. So you guys should be fine with everything with your Chromebook and everything that we are using here. But the goal is to create an abstract drawing similar to a spiral graph drawing using loops and iterations. Examine the effects of infinite loops and zero iteration conditions. Predict how many times a loop will iterate. And experiment with the effects of an operating precedence on code execution. All right, and then, remember, we can go back to Turtle. This is just a resource here. You guys can open it up. And it should tell you everything about the Turtle methods that we can use. Okay, zero iteration conditions and infinite loops. In the last activity, you modified loops, mostly using the less than or modulo operators to achieve different effects. In this activity, you'll gain more comfort with loops and learn how to troubleshoot situations in which loops don't seem to be behaving as you expect. Either your loop never starts or never starts. Or say that backward, never starts or never stops. You can also use mathematical operators and orders of operations to modify the behavior of your code. This will give you more flexibility when you attempt to solve problems or create unique effects with loops in the future. So read the comments in the code below, then run the program to see if it behaves as you expect. So let's see, we read here, we got import turtle, we set them up, make them a square, color is salmon. Line equals 5. The value of line starts at 5. While line is less than 5, the value of line is less than 5, which that never will be. So if we run, what happens? And not much, right? I'll grab a drink here. So we get an expected error here. The contents of the loop with the zero iteration continue will not execute. The code below, the code you just examined included a zero iteration condition, explained in this example in your own words. So didn't need to make this really a question here, but yeah, it never worked because the line is initialized greater than the starting condition of the loop. So next, we're going to modify the code so it draws 5 circles. So same thing here. Okay, well, how would we modify this code to draw 5 circles? Well, we don't want line to start at 5. I mean, there's 2 different ways here. We can make it line start at 0, make it run. There's 5 circles. The other way we could have done, left at 5, just make line 10. Does the same thing. Okay. Run the program below and note your observations. Okay, so looks like it's going, the arrow is pointing in the same direction and it's making circles and it's changing colors, right? If we look for the find, line equals 6 while line is greater than 5. Well, if line is 6, that's just going to make this run forever. Line equals line plus 1. So that means it's going to keep on going up and up and by 1. Okay, here we have the modulo 8. So this is where it's changing from navy to salmon. So we're just constantly building a list starting with 6, 7, 8, 9, 10, 11, 12. And we're going through and after 18, we go through here and change the color. All right, so that is an infinite. I'm going to just stop that here. So hopefully nothing, because that's running forever. All right, here's another example of an infinite loop. Doing the exact same thing, but what did the code do differently? It's making line start at 4 and it's always going to be less than 5, and we're making line go down by 1. So it literally does the same thing. So all right, so there's part 1, just a little warm-up activity. Here is our submission here. So part 4, or part 1, question 4, create your own object that includes a zero iteration route and an infinite loop. The turtle methods that you use, we can open the page in the new browser. Yeah, we can. So for a zero iteration loop, include a turtle move that would occur if the iteration were non-zero. All right, for an infinite loop, show turtle and demonstrate the loop. Okay, so let's make a zero iteration loop. let's just have the turtle, well, it would do nothing, right? So we can make like count equals, 0, while count is greater than or less than 0. Painter dot, we'll do something simple, forward 100, painter dot right 90, and then we'll do count equals count plus 1. Oh, actually, it needs to be a non-zero. All right, well, here we go. Change this 1, change that to 1. So this will be a 0 iteration. This will never work here because the count starts out as 1, and 1 is never going to be less than 1. So, and as we add 1 to this, it won't even matter. We probably don't even need to do that because that while loop wouldn't even work. All right, now in an if loop, we could probably still keep count equal to 1. And we'll do while count is less than or equal to 1. Let's do painter. We'll make, should we make it something else here? I know what we can do. Painter dot forward. We'll make it go forward the count amount. And then painter dot right. We'll make it go just like 20 degrees. And then count equals count minus 1. So I'm guessing here what's going to happen is the painter is going to go forward. Actually, it's going to go backwards. Well, it's going to start at 1. And right, yeah. And then it will go forward 1 spot, turn 20 degrees, and then count goes to 0. Then it's going to go forward 0, turn. So let's run this and start to see what happens. Whoa, and we're spiraling out of control here. Wow, that's pretty cool. All right, so there's a nice, oh man, I'm just getting insane here. So repeat, there we go. All right, so there's a good submission. Don't have to get too crazy unless you really want to mess around. Okay, so let's move on to the next one. So part 2, once again, this is just kind of like our notes, but then we'll do the submittable at the end. So arithmetic operators and orders of operations. Do you recall learning about orders of operations in your math class? I like math. The orders of operation is important because you can calculate arithmetic operations in a math problem in the wrong order. You'll get the wrong answer. So similar to mathematical operations, a computer follows the order of operations to execute a program. You can use the order of operations to modify the behavior of your code. The acronym Pemdas is often to recall the order in which to perform arithmetic operations. Do you remember what it stands for? Please excuse my dear Aunt Sally. Parentheses, exponents, multiply, division, adding, and subtracting. So note, in the event of a tie between multiplication and division or addition or subtraction, they're performed from left to right. So here you guys can see we got like 6 times 10 divided by 5 times 2. We're going to go work them from left to right. So we do 6 times 10, which is 60. Divide that by 5, 12. Divide that by, or times that by 2, and we get 24. All right, the modulo operator has the same precedence as times, divide, and divide. So once again, we work left to right. So 6 times 10 is 60. 6 divided by 5 is 12. 12 modulo 3 is, think about it, 0. 12 divided by 3 has 0 remainder. 0 times 2 is 0. Okay, so Python has some operators of its own, such as the dot operator, i.e. the dot in the painter. So that dot right there. It's also considered after parentheses before any other mathematical operators. Parentheses are a good way to force orders of operations. So let's examine the 2 programs that follow and use the arithmetic operators, the same numbers to move the. All right, so if we look at here, how forward is that going to move? So I could have made this problem, but let's see. We're going to do the parentheses. 4 minus 5 is -1. Let's go inside here. 18 divided by 4 is like what? 4.5. 2 minus 4.5 is -2. And then we multiply 7 times, or -2.5. 7 times -2.5. Man, now we're getting tough. Negative 14, 17.5 times 2, negative 35. And then we finally have here the -1, so -36. So we want back 36 pixels. Same thing here. All right, just another math problem. All right, so do the inside part here. 2 minus 18 is -16, divided by -4 is -4. And we can times that by 2 is -8. Okay, we got to figure out what's going on here. We did this parenthesis, that's 12. 12 times, was that -8? Nah, I probably should write this down. Is 12 times -8 is -96. 4 minus -96 would be 100. Moves over 100 pixels. And we can double check that by making another one here at the same length. Okay. So let's go to this part here. Using your knowledge of mathematical operations to write a program, write the following algorithm. Ask the user to enter 2 numbers. Determine if the first number is divisible by the second number. Remember that the exclamation point equals compares an inequality, compares for inequality. See if it's not equal to. Repeats the steps A and B till the numbers are evenly divisible. Okay. So I'm going to just open this up here. We're going to go through our steps. I'll move my noggin. Get 2 numbers from the user. Okay. So we can say like A equals input. Give me a number. And B equals input. Give me another number. You know what we should do here is make sure that they're whole numbers, so we'll ask them numbers. Okay, and then the problem is where we're doing math here, so we need to make sure we get them as integers. So A equals the integer of A. You could have nested this in as well, integer of B. So we made A and B both integers. We're gonna make a loop. While the numbers are not divisible, the remainder is 0. Okay. So let's do this. So while A modulo B does not equal 0, we'd have to tell the user, so we'd have to say print the 2 numbers are not divisible. Print, let's pick another 2. So then we're going to get the input from the user. So then we're going to say A equals the integer. Actually, I'm going to just copy this whole thing down here, right? Because we're going to get the, and I'll have to tab them in to make sure that they work appropriately. So we get another number here. Now, once this will stop once they are divisible, and we'll tell them print the 2 numbers are divisible. Okay, so let's check this out. Let's run and see how will this work. Give me a whole number. So I'm gonna just say like 5 and 7. The 2 numbers are not divisible. Let's pick another 2. Give me a whole number. Okay, so 11 and 13. Once again, we get the same thing. Okay, 8 and 81. The 2 numbers are not divisible. This is where it's going to get a little tricky here. And I think I'm going to have to make a change here, because if I say 9 and 81, those 2 numbers are not divisible. You can kind of argue that they are, because if I did 80, well, yeah, 1. But if, let me run that again. If I did 81 and 9, 81 and 9, those two numbers are divisible. So maybe we might want to add to this while statement an or, and we'll do the same thing, just switch the order. B modulo A does not equal 0. So let's double check that one. So if I still do 5 and 7, it doesn't work out. 13, 15 doesn't work out. Now 9 and 81 says those two numbers are not divisible, but it should be 80. 81 and 9. Those two numbers are not divisible. Oh, now we're messing up. All right, hold on. My kids ask me. I'm gonna. Okay, yeah, I just realized here it probably should be an and. So while we switch them around, so not an or, because that would mess up. So let's stop and run this again. So give me a whole number. 5, 7 is bad. 13, 15, bad. 81 and 9, those are divisible. And then we'll just run again to check 9 and, 72. Those, okay. So there we go. We had to put an and. I'm thinking backwards here with the not equals to always kind of messes me up here. All right, so that should be a submittable. We get the information from the user and we just keep running this loop until they actually pick the right numbers. Okay, so this ends 114. Hopefully you guys are doing great. We're moving along and grooving here. You guys have a good day. See you next time.